Hello guys, my name is Ewere. Um I'll be presenting today and I'll be giving 9 strategies to improve UX on your AWS Cloud deployments. Um I know we all know what user experience means, but I'm gonna explain again and then give a little definition. User experience basically talks about how your users experience and connect to your product. So be it a website, be it a mobile app or whatever it is, but it has to do with what kind of feedback your customers have. Is it a fast website? Is it a slow website? And this little feedback is enough for you to get more customers or to even lose customers that are already existing on the platform. So it's very important that you have a very good user experience for your users, whether your system is down or not. And we'll be focusing more on when your system is down. So I've given 9 strategies on how you can manage your systems and make it better and let your user get a better user experience. So a little bit about myself. My name is Ewere, which I already said, and I've been a software engineer since 2003, and I started programming in QBasic on Windows 98. I've also worked with various programming languages such as Node.js, Python, and C#. I currently work at Synfix as the head of infrastructure and security. When I'm not on my Linux shell or my Amazon console, I blog at Medium, my cloud series, and I watch superhero movies such as The Flash and Arrow. I'm also a father of 2 lovely, beautiful girls. So that's just a little bit about myself. And then we'll go deep down into what we'll be talking about today. So the 9 strategies for better user experience in cloud deployments are as follows. So we have degraded performance, we have the DNS and static failover, we have the DNS latency, we have CDN and caching, we have load balancing, application caching, appealing status page, mean time to recover, and then hide exceptions and errors. So without further ado, let's go into each one of them and understand how to use the strategies. So the first is the degraded performance strategy. So this is a state when all the features of your applications are not available for the user, but certain features are still available for the user. Now, microservice for the backend makes this possible, and using S3 can be very helpful here. So what we're talking about here is when a user comes to your website and there is a problem, instead of having a total shutdown of all the services in your system, you can still have some services running. So take for example, if you build a particular application, a particular system, and you don't use microservices, what do you experience? The whole system goes down. Okay, your billing goes down, your shopping goes down, your cart ordering goes down, your categories, everything goes down, your catalog goes down in your application. But if you build in a microservice architecture, your billing system could still be working even when your add to cart has a problem. Your categories could still display items in your shop even when your add to cart still has a problem. So it gives the user a better experience of having to still have some features working to some extent and some not working, so you can always control the failure of that particular system. So the user might not have the full experience they should have, but at least it doesn't give you a blank page, or it doesn't give the user a page that makes them not understand what's going on. So with your degraded performance, you can actually manage the kind of feedback you give to your customers. You could tell them, oh, we are sorry, the system will be back up in no time and all that, but it doesn't give the user a full experience. But at least the user doesn't have to see a blank page or a page that doesn't explain or give the user what to understand, something to understand that the system is not actually fully functional. Now S3 has very high availability, making your front end always available. So with S3 actually this experience becomes much easier. Now the reason I call S3 here is you can use any other web server, okay, Apache, Nginx and all, but when that web server has a problem, there's a high chance that your application and your main server will all go down at the same time. But S3 has a 99.99% availability, making it very available. So even if any of your microservices, your backend is down, your S3 also makes it possible for you for users to view your website, and they can actually see, and you can relay a message back to the user that you are currently experiencing some issues and you'll be back in no time. Now the use case here is with your microservices, your whole system does not go down at the same time, and some services can serve customers while you work to get other services back up. Now for the AWS tools that you can use to implement microservices, so you have EKS, which is an AWS wave of Kubernetes. So Kubernetes helps you to deploy, manage, and orchestrate containers in a microservice architecture. You have AWS ECS, which is AWS Elastic Container Services, which contains Fargate for serverless and also for normal EC2 instance. And then you have the serverless Lambda/API gateway integration, which can also be used to build microservices and make each particular component of your system a single service of its own, instead of having everything coupled together as a single unit. Now, the next strategy here is DNS and static failover. Now, having a static failover option of your website hosted in S3 can help give your users a very good experience. Even when the dynamic site is down, AWS Route 53 can detect failed endpoints and route to the next available endpoint, giving your users the same experience without the knowledge of downtime or service unavailability. Now, one time what I did was that I took the WordPress version of our website and converted it to static content, which is HTML, CSS, and JavaScript. Now, that is a feature of S3. Okay, S3 is able to serve websites static content. When you have HTML, CSS, and JavaScript, you can actually deploy it to S3 and make it available on the internet, and then mount a domain name to S3. And S3, we already talked about having very high availability. So with that, you can actually configure a DNS failover, which I'll be demoing very soon, and you see how you can actually make sure that even when your users have a problem or your website goes down, your users might not actually know. AWS Route 53 will automatically help you route requests to the S3 option, which you already have available, while you try to fix the problems in the main website. So an example here is making a static alternative of your website and having it available on S3 to serve static content when the main application is down. So for example, you have a website that has very huge traffic, say a WordPress website, and for some reason your MySQL has a problem or the application goes down. Maybe there's a plugin that is installed in the WordPress and it makes it go down. Now, before you actually deploy the application to go live, you could make a copy, okay, a static copy. There are tools for making static copies of WordPress. You could make a static copy, and when that static copy is available, you configure it on Route 53 to say, when the primary server fails or the primary endpoint fails, switch over to this secondary endpoint. So what happens is, when Route 53 does a health check and discovers that you get any kind of status code that is not a favorable one, say a 4xx or a 5xx error code, it will automatically route those requests to the S3 option, making your website still available. So when users come to your website, they actually don't know whether it is a dynamic or the static site, but they have something to view. And if they try to trigger any kind of dynamic activity, you could actually send a message and say, we are temporarily down, but we will be back up in a short time, which gives the user more confidence that, oh, these guys are working on something, instead of just landing on a 404 page or a blank page without actually understanding what is actually going on, feeling like that website is actually hacked. So it gives the user a better experience to understand that things are being worked on. Now, the tools in AWS that helps you to make this particular feature possible is AWS Route 53, which is AWS DNS service, okay, and then you have AWS S3, which is for storing files and also for serving static content website. Now, the next strategy we can look at here is DNS latency. Now, the speed of your website is quite important to your customer, and it takes milliseconds of delay to lose customers. Now, having latency very low is very key, and using servers closer to your customers has a way of helping to reduce the latency. This way your users get a better experience. Now, I cannot overemphasize how the speed of a website is very important to even you as an engineer. Okay, when you're working and a website is quite slow, there's a high chance that you might not want to go to that website because people are actually not patient to wait, and that patience is not what is available all over the world. So when your website is slow, it becomes a problem. It gives very terrible customer experience, it gives very terrible user experience, and the user might be so angry and might not want to come back to that particular website just because of the speed of the website. But DNS latency helps to improve that, in the sense that when you configure the DNS latency on Route 53 in AWS, it helps you to verify which of the servers you have that is closest to the user and saves the website from that particular location. That will also help to improve the speed of the website and ensure that the user has a very good experience in visiting that website. Now, the use case of this is routes requests to a region closer by profiling either the load balancers or the IP address or the CDN address on Route 53. This will improve the speed of your application. So Route 53 has what you call the latency routing that helps you to route requests to a web server that is closest to the user. Now, the option here is you need to have profile more than one particular endpoint or one particular IP address on the DNS layer. So what the latency configuration does is it does a ping, and the fastest run time is what it's going to use and serve that particular customer depending on where the person is on the globe. So it doesn't just choose randomly, it chooses based on latency. Now the next strategy here is the CDN and caching. Now POPs. So POPs are points of presence. These are little data centers. Okay, they are more minute data centers in the cloud where caching occurs. So caching is having to have a copy of your website somewhere in the globe, making it faster for users in that particular region to access that particular website. Now, POPs globally help to store your CSS, HTML, and JavaScript closer to users. The difference is clear when there is a CDN closer to a user in Japan visiting your website than when the same user is visiting your website on a server in Ghana. So what the POP does and what AWS has done, which they have over 100 POPs globally, is that when you have your website, let's assume you deploy your website in a server in America and you attach a CDN, which is a content delivery network configuration to your website. What it does is that it makes a particular copy across the 100 POPs that AWS has globally. And if you have a user in Japan who needs to visit a particular website, now because the server is in the United States, doesn't mean that the user has to send a request all the way from Japan to the United States. Because you have your CDN configuration, it's going to make a copy of that particular website off the United States servers and make a replica in a POP that is in Japan or close to Japan, making the experience faster and easier for the user to communicate with because of that CDN caching functionality that has been implemented on your website. Now, using AWS Cloud Front to cache static or dynamic content to improve response time of your application. That's a particular use case. So CloudFront is the tool in AWS that helps you to do caching. And with this caching, your users get faster experience, better experience, and the website becomes faster and easier. And then they are able to always come back because they know that whenever they come to your website, they always get a good user experience. So the tools you can use here is the AWS tool is AWS CloudFront, but you can also use Cloudflare, which is quite popular. So CloudFront is fairly very cheap because it's quite serverless, and so it makes it quite cheap to use. The next strategy here is load balancing. Now, during the periods of high traffic, you do not want users to experience a downtime because you're actually trying to scale up or you're trying to scale down. Now, during high traffic, so load balancers can help spread traffic during times like this. Now, what is a load balancer? From the name, load balancer. So when you have a lot of load and you need to spread the load or you need to balance the load to ensure that your website does not have a downtime or your website does not have a very slow user experience because your initial server is being used up of resources, say CPU and memory, you employ a load balancer in front of all your servers, making sure that you can do what we call horizontal scaling, which means you can add more servers as your request grows and have a load balancer route the traffic across all the servers. Now, what the load balancer will do for you is that it will make sure that either the user experiences a degraded performance or the user experiences a good performance, but you don't have a downtime during a scaling period. So if you need to attach a new server to the load balancer, at that point in time, you are trying to attach a new server, start up the new server for the load balancer to recognize, the user might actually experience low latency. Okay, the latency might be very high. Sorry for that. Latency might be very high because the user is trying to connect at a very fast rate and more users are connecting and the resources of that single machine is not able to handle it. So instead of shutting down that server and waiting until the new server comes up and all, you attach a load balancer in front of your architecture. What that does for you is that it routes the traffic across the server. So whether a server is there or not, it makes sure that it continues to route requests to the extra servers or non-extra servers that exist. Now, what you're going to experience is degraded performance. So if you have a single server of say 4 gigs RAM and for some reason there is a spike in your memory, you don't need to shut down that server and say, oh, we need to scale up or we need to upgrade. No, when you have a load balancer in front of that server, you can actually register that new server to your load balancer. When you do that, your traffic becomes spread across both servers and improving the performance of your system. Now, once the performance of your system improves, the user experience gets better. So the user will not experience a total downtime that doesn't make the user understand what's going on and the user is confused. No, the user just experiences some drag in the application. And when your load balancer registers a new server you add to your architecture, your performance becomes better because your load is now shared. The memory is now shared. Instead of just a single 4 gig machine, you have a 4 gig machine or a 2 gig machine, depending on how you want to do it. And you can add more servers as you grow without having to shut down and have a total terrible user experience that will make the user not come back to your website or feel your website is slow or you are not serious to do business. Now, applying a scalable load balancer like AWS application load balancer or classic load balancer will give consistent experience to the user, so the user doesn't experience a downtime. Now, the AWS tools that can help you with this a lot is the AWS application load balancer, the classic load balancer, or the network load balancer. Any form of load balancer you choose, so they give you the same user experience. Now, application caching. Now, faster login and quicker access to data in cache gives the user the feeling of speed in your application response. Now, most times when you build applications, people use your relational databases, so your MySQL or any other kind of database for storing login for users. Now, what happens over time when your application scales over time is that the round trip to your databases becomes too much. Okay, you need to do a login. You always have to go to your database to perform a search to validate the user before you give the user access to that particular application. Now, when you start handling over 10,000 logins in a second or 50,000 logins in a second, that will put a lot of stress on your database. And don't forget, your relational database stores data in disks. Now, the time it takes to read data from a disk is usually very, very slow. Okay, even with your solid state disks, okay, it takes a while to read data from them. But with an application caching, okay, using a system such as any kind of caching system that exists, okay, caching technologies, what they do is that they store that particular data in memory instead of your disk or your hard disk. They store it in the memory. So when they store it in the memory, what happens is that the application becomes faster because it is faster to actually read data from the memory than from the disk. Okay, so instead of application round trip to your main database, you could actually cache certain information in put certain information in your cache, and then caching technology store data in memory, making I/O faster, thereby making the application faster. So if it takes roughly 20 milliseconds to do a login operation, or say 200 milliseconds to do a login operation with a relational database, it could take less than that, half or much less than that, to do a login with a caching system. So that alone can make a user either stay or leave because the experience is beautiful, the experience is great. You know, you don't want to count how many people love WhatsApp. Okay, now part of the things WhatsApp do is that they perform the login without even you noticing it, because they have to authenticate and validate the user at every point in time during a chat session. So things like caching technologies are what people like WhatsApp use to ensure that the user gets speed and consistency whenever they are actually using their application. Also, applications like Facebook, okay, Facebook uses a lot of caching for a lot of operations, ensuring that you get that speed, so they don't have to do a lot of disk I/O operations. Instead, a lot of the operations happen on the memory layer to improve the speed of usage. Now, use a cache service like Redis or Memcached to store login information, so users can log in via the cache and not the main database. Now, the AWS tool for use here is actually Elasticache, AWS Elasticache, which can either serve Memcached or Redis. Now, the next strategy is using an appealing status page. Now, how many of us get so annoyed when we see this kind of page? Okay, it's annoying when a user sees a page like this. They actually get confused and can expose your application to a lot of vulnerabilities. Now, looking at this alone, I already know that you are using an Apache server, okay, on this particular server with this error code and this status code 404. And then most times when a user gets to this page, they might never come back to this page. Best case, what the user will do is to refresh the page, and when they refresh twice or thrice and nothing happens, that's it, they are gone. Before they can come back to this page, it becomes difficult, because we know that attention span is actually very valuable at this point in time. So you don't want your users to see this kind of page. It's going to put them off. It's going to make them not understand what's going on. It's not giving them a way to navigate out of your website. So they just go to your address bar and they go somewhere else where they know they can actually do what they need to do. In certain scenarios where a user is particularly searching for content and Google indexes your website, and for some reason that page doesn't exist. So when a user lands on this page, they are just put off immediately and they just leave. They might never come back again. But having to use appealing status pages such as this, okay, this gives a user calmer, and user can still navigate. Okay, if you look at the first page, it tells you so sorry, it tells you page not found, so it says bugs is having a hard time finding the page you've requested. Please try our search box above or try one of the following links, and it gives you links for you to try. And look at the second one, it tells you oops, sorry, we couldn't find it, and then you have links where you can follow. So these appealing status pages are very, very essential and crucial. You hardly see this kind of pages in very big websites such as Facebook or Google, because they try to handle it and give you this appealing status page so you know how to navigate. In some cases, they actually automatically redirect you to the home page when there are 404s like this that exist, or broken pages within the website. So what the moral here is, handle all HTTP error codes and route to a static page in S3. S3 is coming into play here because of the high availability of S3. That's why you see S3 coming into play a lot. Now, always handle your status code properly. And then the use case of this is using what we call AWS Lambda at Edge or CloudFront. You can actually route based on status codes or configure your web server to redirect to a static page. So when you have a status code, a 404, a 4XX or a 5XX error on your website, you don't need to keep the user in a state of confusion like the 404 page that I initially showed. Some websites you're going to see 500 error. You need to contact your webmaster, blah blah blah. Things like that are not so appealing to the user. The user gets stuck, the user gets confused, they don't know what to do. So what you can actually do to give the user an appealing experience is to either use AWS CloudFront, okay, which you can use to actually route requests to your S3 where you store your websites. Or if you don't use AWS, you could actually configure your web server to say, okay, when there's a 500 error, route to this particular website, which could be a website in S3. Now, the reason for the website being in S3, or the file, just a simple HTML file with a simple message of we are sorry, we'll be back soon, and then maybe a link that links to the home page of your website. The reason for using S3 is because of the high availability of S3. That's why you see me talking about S3, S3, S3. Okay, now the AWS tools that you can use here is CloudFront, Lambda at Edge, and S3, obviously for serving the website. Now, mean time to recover is another strategy. Now, your organization should have a stipulated service level agreement for all services. That's an SLA, uptime, and then mean time to recover. Using tools like Uptime Robot can be very helpful in understanding service health and measuring mean time to recover, which will be communicated with customer in eventuality of a downtime. Now, how many times do you notice that even when some websites are having issues, operational issues, take for example, once in a while you notice Atlassian or Bitbucket having an issue. Now what you notice, there are two things. One, you get a degraded performance, which means you notice that some features might be working, some features might not be working, which is the first strategy I talked about, which is degraded performance. Now the other thing you notice is they have a status page, which helps users to actually know the status of services, okay, which is exposed to the internet. You can actually go to that status page and watch the status of what is going on. That's one. Two, there is also communication of resolution, possible resolution time. Now they might not know exactly when they are going to come back, but having to communicate to the users that we know there is a downtime, we know that this is actually impeding and causing harm to your business at a particular point in time, but we'll ensure that we'll be back within the next 1 hour. If we are not back in 1 hour's time, we're going to communicate to you again about the next time we'll be back up. Now, this is how you communicate the mean time for you to recover. Now, sometimes these numbers are calculated based on previous failures that you have in your system and how much time it took you to recover. Now, when the user knows that they get feedback, okay, timely feedback, they know how to plan, they know how to structure their work, they know that these people are on the job. But when there's no communication, there's no feedback, and you don't have a beautiful status page to actually communicate this, the user is put off balance and they don't understand. And trust me, in financial systems, you don't want this to happen. It's going to be a major problem. People will become afraid of their money. People will be afraid that their money is gone. So you need to always communicate to the customer. You need to always communicate to your clients that things are being worked on. We are on the matter. We are trying to make sure this thing gets fixed as soon as possible. And the best way you can get your mean time to recover is based on past failures. When you have an average of that time, you can communicate that time to the users. Now, it might be a major blackout. It might be a minor blackout. But having something to communicate with your customers is very essential to how your customer experiences or feels your product or understands your product. And then the last but not the least here is what? Hiding exceptions and errors. Now, showing users the errors in your application is not only confusing to the user, it keeps the user stuck after seeing your error and not knowing what to do next. Always give users a beautiful error response and not the bug in your code, and the proper way to route them somewhere else. So I noticed this a lot, where you see cannot find or null exception. System had a null exception, object, depending on the programming language you're trying to use. Okay, now you can use exceptions to help yourself out of these problems. Okay, whenever you have a connection failure, an object failure, any kind of third party communication failure, no matter how bad the error of the system you are connecting to is, you need to handle it within your code and ensure that you display a proper a message to the user, because that message is very important. So you're trying to communicate with third-party API, and that third-party API has a problem. The connection is timing out, or there is a problem. You need to show the user, we are experiencing some issues at the moment. We will get back to you when this issue is being resolved. Okay, when this issue is resolved or when this issue is sorted out. That kind of communication alone makes the user understand that something is wrong. But when you see null exception or null pointer or error stack, or it keeps the user confused. The user doesn't know what to do. The user doesn't have any navigation, and in some cases this error takes over the whole page. Okay, there are some ASP.NET errors you notice that it gives you yellow page. Okay, the yellow page fear of the .NET developer. That page can be avoided. Okay, that page can be totally avoided using proper exceptions within your code, and also using the status code we talked about, giving a beautiful status code, status page to the user, showing the user that there is a problem instead of just throwing the exception over to the user. That puts the user off balance and makes the user not to know what to do and where to go. So always give users a beautiful error response and not the bug in your code. Now, use case here is always use exceptions in your application, so the caught exceptions can write out clean and much cleaner responses. So thank you very much, guys.